Hey, so I'm Sean. We're Team 1.
Alex.
No, sir.
Hamza.
Mohammed. Spencer. And we're Team 1 and we're tasked with the power transmission system.
So just kind of a brief overview of our goal here is, well, what we wanted to do is design a prototype of the power transmission system, and in order to get there, we had to design a few concepts. So we kind of threw a few things together, made a few concepts, and we kind of wanted to identify what the desirable functions were and what the pros and cons were, and then from there, based on the feedback from the teams and some other things, we were going to determine the gear ratios and feed rates, and then so for the final step, we wanted to create a prototype of the final concept, and then that's pretty much just awaiting feedback from some of the other teams.
For the assumption that we're going to test is pretty much comparing one motor with multiple motor. We're going to compare the price and horsepower and which one it will be easier to set up.
So this is our first design. We have our 130 horsepower motor here. We have one pulley connected right here. That'll be connected to the extrusion screw, which will require a shaft to reach the extrusion screw. Another pulley will be offset. The mixing and the auger will be offset, the pulleys, so that they can both be attached to the shaft of the 30 horsepower motor. The two pulleys here will be manipulated. Their gear ratios will be manipulated to get the required RPM to each subsystem in the whole system. These two gears here, this gear will be turning upon the pulley being activated, and it will turn this gear, which will run the second component of the mixing chamber before being dropped into the auger.
So this is our second design. So two more design. We have the rear motor powers the two screw, the front motor powers the mixer. Sorry. And this design is more modular because the motors tend to be smaller, so you'll be able to move the motors as need be. Also, it is a little bit cheaper, with the overall cost being about $1,000 less than the previous design. And the shafts would be, you need similar to what top shaft for the mixer, and then you just use a smaller shaft for the extruder. And yeah.
So another consideration we have to start thinking about is how we're going to actually mount the motors. What we want to do right now, unless design constraints come up with how the location of the supports are going to be for this extruder, we want to have it on the ground, just basically with cement with 4 threaded rods cemented to the ground, and then you're able to level it out after that. Also, since there's going to be some vibrations, we're thinking about maybe trying to do a shock absorber mat in between the cement and the motor. These are all still up in the air because we have to wait what we hear back as far as where we're going to be able to put these motors on for the final locations. But the smaller horsepower motors are going to be much easier to work around that problem. So the information required to continue with the prototype is going to be the RPM and torque calculations from the mixing team and the extrusion team. Those are going to be the most important things for us to actually get a working prototype. Right now, I think the extrusion team came out with some horsepower designs with water, but that's if it's going to be above 10 horsepower, then we're going to be out of luck. If we're going to need a 30 horsepower motor, we're going to need to know that.